Hello, guys and girls. Welcome all to the Global Coding Cohort. This is Lekshman here. I hope all of you are doing very well. Today, we are going to solve a small problem, a beginner level problem. And if you have any problem statement which you have faced in any interview or anywhere, you can just post that to me. I have provided the link for the same in the description of this slide. So this is our problem statement. Uh, These two circularly shift all the given input, all the given numbers, all the given. Or I will update the question, okay, a bit. Circularly shift. So our task is to write a Python code to circularly shift all the integers in the given input list towards left L times by grouping minimum number of times and return the updated list. So this is our task. That is, I'll explain it. Uh, we have to accept a list of any size. Those are given in our constraint. That means uh, length of list can range between 2 to 10. Okay, and the number that is present in the list can be between 0 to 9. And then L means number of times we have to shift towards left. Okay, so L can be between 0 to length of input list. This about this first constraint I will explain it afterwards. So I will now explain the problem statement along with an example. So user will give this particular code a list of input. For instance, let us assume that to be something like this. Put list 2, 3, 4, 5. Then user gives L as let's take 2. So our task is this is the input. Okay. So when this is the input, L equal to 2 means it is to shift all those numbers circularly. Circularly means if I move this one step left, then this one should come here. Okay, at this place. So that's it. That's what is mentioned through this word circularly. So in this particular test case, this L is 2. So therefore, we have to shift all numbers present in this array 2 times towards left. So when we do that, we will get something like this. That means the 3 which is present in, okay, first of all, I will write, this is in index 0, isn't it? 0, 1, 2, 3, 4. I will write currently in the input, the zeroth index 1 is present, in 1, 2 is present, and so on. Okay. This is the index. Okay. So similarly, I will write 0, 1, 2, 3, 4 for the output. Okay. So now when we shift this 1, 2 times towards left, as it is circularly, then this 1 from the 0 location will move to 3. L is 2 is 2 times it has to shift. When it shifts 1 time, it will go move to 4. Another time, it will go to 1. Got it? Now 1 is shifted. Then we have 2 over here. Where is 2% currently? It is 1 position, 1 index. It is in index 1. So when it moves towards left 1 time, it will move to 0. Second time, it will move to 4. Now 3. Where is 3 present? In second index. Isn't it? So when it moves 2 times, then that will come here. Similarly for 4, 5. I hope you understood the problem clear. This is index. Okay. This is our output. For your understanding, I have written these index numbers. Okay. Our output is just this 3, 4, 5, 1, 2. But let's okay. I will now explain about this sample IO. Here L is 1, so all the numbers are shifted 1 time. Therefore, we have got 2, 3, 4, 5, and 1 over here. That's the output. Okay. So now I will take the second test case. Two, three. In our question itself, we can rate something like this. By looping minimum number of times, we have to achieve this task by looping minimum number of times. So that means, obviously, here we have to use loop also. It is telling us to use loop. Okay. In other ways also we can do it just by using the slicing concept of list. If someone don't know that, you can go and watch all the previous videos where I have explained all the basics. So there are many possibilities, but here through this line by looping minimum number of times, the question is asking us to use a loop compulsorily. Okay. Also, not just that, minimum number of times. We have to loop minimum number of times. That means for our previous example, when we had 2, we just that means one way is to move all the numbers based on their index. That means uh, if we have five input, then we can shift one. We can take one by one. That means we can take one and shift it 2 times. Then 2 shift it 2 times. Likewise, we have to shift it based on their index. But what's written here over here is minimum number of times. Not just that, we have one more constant over here. The time complexity of the solution code should be around O of n by 2. That time, let's check. If we take one by one, that means when we have 5 elements in the list, then we will have to shift 5 times, isn't it? Which is 5 times means loop will run for 5 times. That means n number of times. It is equal to n. But whereas our constraint is to meet this n by 2. That means not exactly, but around. Understand the word around. Okay. We are not. The question is not asking us to exactly meet the constraint, but it has to be somewhat around that n by 2. Okay. So that means we cannot if we cannot take these elements one by one and shift it. Obviously, that solution we cannot use. Is there any other way? When is that problem arising? Let's see. When we are shifting, okay, we have another method to solve. That is, I will take this number. If my task is my L is 1, then I will put this one at the end of this list and delete this one. So initially I told you to shift all the numbers based on their index. That will run for n number of times, isn't it? So what I'm going to do is, and for L is equal to 1, I will take the first number and will put it here. Now let's check whether all the numbers are, that means in this case we will get something like this equation. 2, 3, 4 and 4, 5 and 1, isn't it? Whether one is shifted, that means whether all the elements are shifted one times left towards left. Yes, those present in that means 2 which is present in 1 has now present in 0, isn't it? But in this way of solving also there is a problem. That means when it is 1 it is fine, it is okay, that obviously less than n by 2, isn't it? Okay, obviously less than n by 2. Okay, I updated this constant. Okay, should be less than or around n by 2. So around means, for example, if n by 2 is 5, then the number of looping can be either 4 or 1 or 2 or 6 also. When n by 2 is 5, it can also be 6 or 4. That means this is around 5. Okay, that is what is around. If n by 2 is 5, then 4 or 6 times it can loop. Okay, that is its meaning. Uh, okay, when n is 1, there is no problem at all. That means obviously it is going to loop for one time in this particular way. That means I'm just going to shift this, move this one to the end of this list. I'm going to delete the first element. That's all. So see here, to reach the target output, just one loop will do when L is 1. But think about the situation where L is 4, and that is what the scenario this second test case is describing. When L is 4, when we try to do the same, that means when L is 1, we just move this one to the last, okay, and deleted this particular one. But think about this 4, we have to, when we do the same for all the numbers, then for L is 4, I will first, uh, okay, I'll first move 1 to end of the list, then 2 to end of the list, 3 to end of the list, 4 to end of the list. Then automatic, that means I'm not just moving, I'm also deleting the element that is present at first. When I move for 1, I will move 1 and delete this first one. Then I will move 2, then delete this first 2. Got it? When I do those two operations, we will get something like this. But in this type of solving, the loop ran for 4 times. When n is, that means n means length of list, okay? Here n means length of list. N length input list. Correct. So what is n by 2? When n is length of list means 5 by 2. 5 by 2 means 2 2s of 4. So it is somewhat like this, isn't it? Obviously, we do not have an index called 2.5, so we will round it up, okay? Uh, so at this case, this number of loops, 1, 2, 3, 4, 5, 4 times we looped over here. Obviously, this is greater than our n by 2, isn't it? Whereas, what do we need? Our solution should run only around 1 by 2. It can be either less, loop can run either less than or around n by 2. Obviously, this is greater, so we cannot proceed in this particular way. So what I'm going to do at this point is, whenever I'm going to add a if statement over there, that means now I looped 1, 2, 3, 4 and moved it and erased this. Listen. So whenever what I'm going to do now, obviously this method is not feasible fully. That means till n is equal to 2, it is working fine. But when n is becoming when L is becoming 3, it is not working. So just this logic will not work. So I'm going to add another logic, that is whenever L is greater than n by 2, that means, for example, let's take the same scenario. When L is 4, that means the previous in our previous logic we will move 1, 2, 3, 4 to the end and we'll delete it, isn't it? But now what we are going to do is L is 4. Sorry, I forgot to length of we have to mention length of input also, okay? I forgot to write that. So we have to give length of input also while we give the input. So there are totally 1, 2, 3, and sorry, 1, 2, 3 input. Okay. So when L is 4, uh, n means length of input, isn't? That is, in our case, this is 5. So what can you understand is when we try to solve this problem from the beginning, then it will take 4 loops. Just think reversely. What if you are trying to move this 5 from this last to first and delete this last 5? Then in one loop itself we can get to the solution, isn't it? That means our expected output can be met in this one loop, first loop itself. Understood? Previously, we were just simply blindly uh, moving all the elements from the beginning. But now we are tweaking. Whenever this L is greater than our n by 2, we are going to do the operation in reverse. So that maximum for our solution code, see, When L is 1, this 1 will be moved to last and 1 will be deleted. When L is 2, 1 and 2 will be moved. When L is 3, as it is as the length of this is odd, okay. When the length of input is odd, it's not going to matter. But when it is even, we will face equal to scenario. Okay. So here there is no problem at work. But obviously, this L is equal to 3. That 3 is obviously greater than or n by 2, isn't it? So therefore, what we will do means we will reverse the operation. Till L is equal to 3 for odd number of input. Okay. Till L is equal to 3, we will move the elements present at first. After when L is greater when from 3, that means after from 3, not after 3, from 3, as 3 is greater than n by 2, we will reverse the operation. Okay? We will start to reverse the operation. That means we will move last to first and will delete the last one. Okay, I will understand more. Write the solution code. Okay. Put me. So this logic will work perfectly to meet all our constraints till L is less than or equal to n by. After that, for L for all L which is greater than n by 2, it will not meet our constant. Okay. Constant means is first constant, time complexity. We are going to treat that accordingly. L is odd, the count is, that means n by 2. Okay, that is what is mid. Okay, so not L, sorry, length, length of input, length of input. We will do the adjustment after we get the result. Okay, how many times by using this trend I is looking for one time. Three, is not 0. Okay, instead of 1, we have to give 0 over there. If L less than mid, let's keep it slow. Let's give L equal to 3, 0, 1, 3. Instead, it should have more 5 to calculate just 2 times. This will do. Zero, 1, 2. Let me run the input list. The reverse path is getting routed. Is 3. It is better to move two things, isn't it? These 3. Three, 4, 5, 1, 2 should be our answer. For L is 3, isn't that means okay, okay. 4, 5, 1, 2, 3 should be our answer. For when L is 5, it should not run. We will handle that later because there is we have to maximum. Either it should be less or around, isn't it? For 5, it is running for 5 times. We will handle that later. For 0 and 5, we should not look. That same input itself is our output. Instead of writing here, I will first hold the loop. Because anyhow, it is going to run for 3 times. Uh, Whenever L is first hand is loop, greater than equal to 1 L equal to L. First, let's confirm here itself. Uh, let's proceed with the loop. Loop Then make this okay. 2. What about loop 2 or 3? For 3 is again same 2 loop. For 4 it is 1 loop. Okay, fine. This 2 loop will work. For 1 loop. See, you can see the difference. One loop for expected output also. So this part is getting executed. Okay. Then two loop. Again, this is less than or mid. I'll print the mid also. Okay. So that you can come back at least using that. So already almost printed here. And for 3, it is for 3, it is 2. In our initial logic, it would have moved for 3 times. Okay. For 4, it is now 1. In our initial logic, it would have run for 4 times. Now only 1 time. So this condition got satisfied. In many ways you can do, but we want to satisfy these needs. Okay. Then for 5, it's not running. Then for 0, again it's not running. So our solution is perfectly working. Let's now give. Now we gave an odd number of input. Now let's give an even number of input. That is 4. Okay. Let's see how is it responding. For 1 loop, for 2 loop, for 3 expecting same 2 loop, for 1 second. I'll check one more time. For 3, left shift to 3 means then our output should be something like this. Okay? This is not correct. We'll check for our odd number of input also. For 1, it is correct. For 2, for 2 is wrong. We have to handle somewhere. Something is going wrong somewhere. Okay. For 2, our output is expected output is 3, 4, 5, 1, 2. Whereas we get 4, 5, 1, 2, 3. Loop, loop 2 times. Then L is 2. 3, 4, 5, 1, 2 should be our expected. Should be our result. Okay, when L is true, we need our first half to get executed. So loop is true, L is true, three, four, five, two. Is it correct? I hope you would have understood what to correct what mistake where I'm tweaking the logic. This is what I want to convey also. That's why I'm coding during the live session. So that you can understand how I'm thinking and how at what part am I touching to get the desired output. Check for one, for two is correct, for three, then it's correct, for four is correct, five, for zero, then let's check the same in four, put number four, okay, zero, correct, one, correct, two, correct, for three, correct, for four, correct. So it's working for all the logics. Here we do not need this if condition, just the this need itself. That's what are saying. Zero. Once again I will check. Okay. One, two, three, four. For odd number of inputs. One, two, three, four, five. So within n by 2 number of loop itself, we are able to produce our expected output. So this is what is mainly defined in this first constraint. Alright. Now you can check this with different input. Okay, check this with different input. Input solution. We have not returned. We are just printing. Okay, instead of returning, I'm commenting out these print statements. We need we can find the time understand it easily. Uh, I'll make this now as the definition. Quick input list, length of input, L. Okay. of this print, I'm going to take this return statement. Okay, this is for initial building and use that input. Now we can give any input list over here. I'll give 9, 8, 1, 2, 5. Even if I give one more, 6, that's it. Then we shift it 2 times. So 10 and 9 gone to back and returned this output. It is correct. Instead of 2, I'm going to give 5. So all the first 5 have gone to last. That means all the first 5 numbers gone behind 3. We have totally 6 number of input. So this is working fine. Just length of input. This is scalable. This input list. Okay. You should not confuse it. That's why I mentioned over here. So that's for today's session. Meet you with another problem segment tomorrow. Until then, bye bye. Make sure to hit this like button. Share a few words about this thing with your friends and colleagues. So thank you. Bye bye.